And it's live.
Anybody else want this?
I think we already know.
Can I occupy that spot?
Go for it.
I just want to.
Sorry. Probably through to another
I was back just explaining that spot.
I think what actually is a
We'll
book.
try catch the battle.
It shows that.
Yeah.
I think so. The fundamental. Oh, you know, I don't. Korean girl.
Oh yeah, yeah. Oh, Helen, yeah, she was there on Saturday.
Yes.
Yeah.
It was Bobby was
Depends on what you do.
compromising picture. It was just for you.
Normally do it if, for example, use third-party library.
Welcome everybody. Today we are on our 8th class. Today we will be learning. Oh my goodness. Today we will be learning about Git. Do we do a quick review of the survey?
Oh,
Yes, actually, we will do that.
And as well, Tristan will be leading the second part of the class, and we'll be talking about vectors. So something which I asked you to read about. But before we get there, so first of all, I'm really sorry about last week. Trouble. Basically, we had the equipment conspired against us and decided to be very vicious in attack. It shows that even Max and even geniuses like we are, we still had a problem. But at the end we managed. Justin, the most experienced developer from everybody, beat everybody with the stick, and he fixed the problem. Which is thank you very much. Now, obviously, big thank you to Ollie and Tristan for leading this class. Again, they are volunteers; they're not paid at all. So it's their kindness and willingness to share the knowledge, and obviously as well Jacob are helping us for free to learn. So big thank you to these guys. On our website and on Skills Market's website, there are further classes. So please do book sooner than later. Why? As you can see, we have now very big space, and the reason being because enough people book. So they say, oh well, they've got enough people, so they put us in a bigger room. If there's a lot of people who sign up very late, they'll put us in a small, cupboard, and then it will be squashed, and it will be, very stuffy and so on. So for your own good, sign up early. There's a page. If you didn't tick your name, please do tick your name, and obviously, then I update you on the website. If there are any misspelling and so on, please do correct and I'll update that. For newcomers, and just a reminder, our class, it's a weekly class. We are available online and we are available in London. So it's happening every Tuesday. Sometimes most of the times we try to be here because it's an excellent venue prepared for that kind of environment. So it's really good. But sometimes when there is a full commercial booking for the place, they won't give us the space, so we have to go. And kindly, Oliver and mine can step most of the time and save us. But if that's not available, we might go to King office, which is in Tottenham Court Road, which you should know. Yeah, so obviously we try to jump as little as possible for comfort of everybody. But until we start paying, then obviously we can't demand. So on that note, if you know anybody who wants to help us with the financial side, let me know. As you knew, we had a survey, and we are true to our words. By the way, there are some free spaces you can see here. Our plan was to basically run the lucky person in class. Unfortunately, the JetBrains had a different idea, and when they issued the license permit, it's for the period, but as well how long can use reclaim the coupon as well, but fairly short time.
One day it turned out, but it was okay in the end.
Yeah, we just why did Ollie, you luckily check? And it's like, oh, and he done a draw, and we picked up. And the winner is Simon Zaminga. So that's the person who won the license. And thank you everybody for actually filling it up. Yeah.
I don't know if Simone is here, but
Well done.
He's away this week.
Is he?
Yeah, he's back next week.
yeah,
Okay.
he said that to me. So,
Yeah.
oh well, in spirit, we're congratulating.
If you need more licenses, email me. My email address is tom@pcservicegroup.co.uk. In a subject, put Sea Lion license, so I have easy life to find your email. And in the body of the email, just put copy your name, surname, and your email address, so I can just copy and paste and email you back. For the most up-to-date
Turning it
information,
down's better.
please do follow me on the Twitter. You'll find there everything. Do we have Steve Armstrong here? No? Okay. So that's all from me. I'm passing you now to capable hands of Ollie. He will guide you through our
Our survey.
survey.
Yes. Right. So obviously we asked a set of questions. We've broken these down separately internally to sort of analyse what the desires are of those that attend in person versus the sort of people that were mostly online. As you can see, we got quite a few who actually said they view it online. So these are the actual breakdown numbers. You can see it's a fairly even split between the two, with a few people who say they sort of chop and change. Obviously, in terms of how people intended to use it, this is basically what we wanted to see. The majority of you intend to attend our classes in sequence as we sort of wanted. But you know, for those that it suits, I'm guessing more experienced people may find there's just certain lessons they're interested in, others they maybe not. But that's pretty much in line with our expectations of what we desired. In terms of how you felt about the classes, so we applied a weighted average to these statistics. So essentially, if it's a 1, then that means you said you felt it was just right, and then if it's tending closer to 2, then something's too much, too fast, etc., or 0 is too little, too slow. So, for example, when we asked how do you feel about the speed of covering topics within each lesson, we had 80% saying just right. So as you can see, the weighted average is very close to 1. There were a few who felt it was too fast, and a few who felt it was too slow, but the vast majority of you said that it's good. In terms of the level of detail we go into within each topic, again, overwhelmingly saying we're doing it okay, and as you can see, it's almost bang on 1.0. In terms of the quantity of exercises we do, the majority of you said it was just right, although there's an interesting point I'll get to in a second that oddly seems to contradict it. But again, it's slightly over here, saying, you know, people saying there's not enough as well. And the majority of you also said, of course, that the length was good, and that the amount of information that we cover across across all of the lessons so far has been pretty much on point. When we asked how well the exercises help you, the vast majority of you, as you can see, said that they're great. They help you crystallise the knowledge that we give you in the lesson, and you find them very helpful. In terms of this big old graph, so again, this was the same sort of concept. You could essentially either say strongly agree, which we would rate as +2, somewhat agree as +1, indifferent was a 0, you didn't care, -1, and -2 if you disagreed somewhat or strongly disagreed. So you can generally see here that the ones that are sort of targeting towards a 2, because 2 is sort of the best score here, then in terms of recommending us, that obviously is quite right out at the front. It's close to 2. The one that was sort of, I mean, they're all. There's only a few that are somewhat under 1, right? So we've got, if I can go with, I would like something. Just go through them one by one. So in terms of the concept of module tests, the majority of you are in favour of this. So we're currently implementing a plan for actually kicking off a module test. We were originally going to do it last week, but then, or we were going to do it this week even, but we keep pushing it because we just have there's gaps in knowledge that I think are crucial to fill in before we get to the module tests. But those are something we're going to pursue. Homework, obviously we know we've been hit and miss with this. We know that the majority of you would like it, so we're gonna aim to do a better job of giving you homework. The special guest sessions, which was sort of an idea we threw out, we've had 1 or 2 of them in the past. Fair bit of people in favour of it. Quite a few who don't care, but it's a 1, so it's overall positive. So we're going to explore that. In terms of recap lessons, quite a lot of you would actually like to recap. So again, this is something we're going to try and organise. Whether we do it on the usual Tuesday schedule or try and arrange something for another day or weekends, we're not sure yet, but we're going to explore that as well. The recommendations, as I covered, wonderful result there, 1.77, very close to a 2. Live coding workshops. We've had these in the past. On our previous session, we did a little Pomodoro sort of 3-week. Was it 2 or 3 weeks that we covered it?
Something like that, yeah.
Yeah, and that was live coding. So we'll probably revisit that again. So we've already got some structure around that option. In terms of sort of unstructured sessions, sort of hackathon style, where you can just play with code. This one was obviously actually still above 0, but a bit below 1. So some of you are fairly keen, some of you not so much. So we might explore that as a sort of separate session for people that want to do it. Fair bit of interest in more than 1 lesson per week, which obviously if we do find the time to do it, wouldn't affect people that aren't interested. I think we'll probably aim to do these in a format that wouldn't necessarily leave you lagging behind if you weren't able to do more than 1 a week. And weekend lessons, people were quite keen, so we're going to try and figure out a way if we can maybe make that work. In terms of why people are attending C++ London Uni, as you can see, it's mostly people want to enhance their job prospects, which is not surprising. Quite a few of you are just doing it for fun, though. Although of course just purely for fun, only for fun.
Yeah.
There's one who's doing it just for fun.
What's wrong with you?
Don't worry, I said the same.
I learned it by just doing it for fun. The job came later, so that's all I can say.
It's true, that's how it starts.
Yeah. See, it's not a bad way, but there was the idea that I could get a job in it, of course. So as you can see, plenty of people saying it's to learn a new language. Plenty. I mean, these are all roughly these are around the 55 mark. Some of them are, there's a non-trivial number of you there who are actually wanting to break into the industry, so you aren't currently a developer. So that was interesting and that was good. We're sort of very keen to help people break into the industry. Minority of you actually are doing it just so you can get out of what you're currently doing. So whatever you're doing right now, you must absolutely hate. But that's fine. Going from I don't know what it is, but if C++ is better, God help you.
You have a pessimist outlook. Maybe they just discovered that they love C++ much more.
Possible.
Yeah.
I mean, I love it. So once you get familiar, it is good. Of course, enhancing your work and career prospects, I think that's arguably a no-brainer. It should be. And of course, as we said, for fun. So just to kind of try and get an idea of what kind of diversity we've got, especially in terms of maybe appealing to sponsors, we just asked if people would tell us if they wished, if they identified as being a minority or disadvantaged or having a disability. And we got a number of people there, so that's nice. We're very happy that we're able to offer accessible courses to people. We want to make this as accessible as possible, so we're pleased with that. But we can, the more the better. And then in terms of our sort of 1 to 5 star rating, we came out at 4.3 out of 5. So the majority of you giving us 4 or 5. We know we've got work to do. The 5 was definitely very generous, but I think overall we're on a good path, and we're constantly trying to improve. And then we just had some additional comments, but those are really for us. So that was it. And before I move on to the lesson, go on.
Just, it might be an appropriate time, given the fact that people mentioned unstructured sessions and weekend sessions, might be an appropriate time for us to give a bit of a shameless plug to Code Academy London.
Sure.
Well, we're discussing this. So basically, we want to ensure that that fits nicely. Yeah. So I will probably check more about that. I mean,
Just to say that people are welcome to.
That's the reason
And do C++
we're talking to Giacomo about that to ensure that that's all that's fit nicely.
Active
Now,
exploration.
the last thing, the reason why we shared with you the result is because we want to demonstrate what majority of you thinking, yes, and we want to give you an idea, what we're trying to do, and that's your answers, what you say, what you do, have an impact. Yeah, so if you help and if you contribute, then you help us to get the right direction, the direction in which you want to go. Not only us, yes, because I might like to do, let's say, embedded stuff, but let's say if majority of the people will not find this at all appealing because it will not help you in any way, then maybe it's something else. But we cannot ask every single person and get confirmation one by one. So that kind of stuff helps. And we want to share this information with you so you can see actually that you're making an impact. It's not just going into void. You click 10 times or whatever and nobody's taking any action from there. Yeah, so that's all, Ollie.
Cool. All right. So one of the things we noted, yes.
Can I just ask one question?
Yeah, go for it.
I didn't really catch the last part where you said, because I sent you an email. Is there something special I'm supposed to write? Some code name or something?
For what? For license. In order to get a license, yes, I need an email. In the subject, put Sea Lion license, so I know when I'm later searching through 20,000 emails, I can quickly filter those emails. And
Sea Lion license.
And the license. And inside the body of the emails, I can just copy and paste your name, surname, and email address. So I can copy and paste. Yes. So as long as I have the license, I will email it to you. If I don't, I'll have to ask for, because I'm not sure if I still have, but basically I have to ask Phil for another batch of the licenses, and as soon as they gave me, I can email to everybody who asks me.
You know skillsmatter.com, right? Not skills matters. I'm gonna temporarily remove this one later. Okay, right. So one of the things we noticed last week was that there's a fair chunk of you who don't know how to use Git terribly well. Hands up if you do know how to use Git and you don't need this lesson. Not many of you, interestingly. Well, so I've got some advanced stuff we're going to throw in as well, so there'll be something for everyone, hopefully. Right, Git good. Source code management. It makes your life easier and better. So here's what we're going to cover in today's sort of set of topics. We're going to have an overview, an introduction to doing your first repository. So while we're here, if you haven't already got Git on your computer, please go to git-scm.com and download it.
Ollie, use the black one.
Right, git-scm.com, Mac, Windows, Linux. We'll be discussing the topic of branching, why it's good, how to use it, and why, if anyone, has anyone here used other version control systems like Subversion, Perforce, CVS, Mercurial? Okay. All right, everyone else seems to be fairly clean, so you're not corrupted by the sort of horrific pieces of words I'm not going to say from history. When disaster strikes, what to do if you make horrible mistakes and how to fix them. Then a little bit on the internals of Git, which should be interesting for the people that already know it relatively well. Maybe if you're a complete expert, you should know it. Anyway, so the overview. So first of all, what is version control, right? Essentially, you've got your source code, right? If we look at the Linux kernel, which is developed by people all over the world, many people. Previously, they literally versioned it by sending zipped up versions of the source code to each other. It was AKA tarballs. They would just take all the source code, zip it up, email it, and then someone would get it and they'd make their changes and they'd email that around. And then they were given a license for something called BitKeeper, which was a commercial versioning system. And the requirement was that they must not reverse engineer it in any way, shape or form. And then one of the Linux developers decided he was going to do that anyway. And BitKeeper got a bit upset at that, and they decided that they were going to take their license away. And they had about 3 or 4 weeks or something like that to actually move to something else. So Linus started looking around. He tried out Mercurial, it was too slow. He tried out Bazaar, but it was too bizarre. And so he decided, no, I can do better than everyone else. I'm going to write my own version control system. And he did. And it was called Git. And I'm sure as everyone realizes here, it's become the version control system. But essentially what it is it gives you points in time. It gives you snapshots of your code. So, you know, I do a little bit of hacking, commit that state. So now I've got the code as it was at that point in time. Do a bit more hacking, throw in another commit. Now I've got a snapshot of that point in time. You can just keep on adding commits, and each commit represents that point in time, and you can go back to it, and you can inspect it. So if you go forward and you discover you've got a bug, you can sort of work your way backwards to see, oh, I know this commit was good, and this commit was bad, so it must live somewhere in the middle. And Git gives you tools to actually find that in an efficient way, which we'll discuss later. So the question is, what should I manage for version control? So because Git gives you the entire history of your code, of whatever you're working on, this means you should ideally aim to be somewhat selective with what you stick in it. So Git is generally designed for, source code, files that are human readable, textual, not huge. If you start throwing, Photoshop design files into it, I mean, you can do this, of course, but if you start combining lots and lots of binary files, like you start putting your compiled output in there, or your compiler's build directory, it's going to get really big. It's going to be really unpleasant for other people to then download from the server you've pushed to all that new code, because even if they've got a fast connection, you could potentially be uploading tons of stuff, which is also annoying for you, right? You don't have to wait ages just to upload stuff. There's technologies that get around this, like Git large file system, Git LFS, which enables you to sort of still version large files, but keep them separately. And the idea is that you shouldn't be, hopefully not be modifying them too frequently. So why Git? Feeding into my story from earlier, I mean, it's got a whole ecosystem, right? There's GitHub, there's GitLab, there's a variety of open source projects that you can use to host Git yourself. You can, pay Atlassian for Bitbucket, stick it on your own machine. You can get GitLab, stick it on your own machine. There's now Gitty, Gogs, all of these website-based Git hosting services. And you don't have to do that though. Git at its core is just a set of tools, and all it really needs is a file system. And if you want to share code, then you need a way of sticking it on a server somewhere on the internet, so you can share it with other people. They can download it. Obviously, stuff like GitLab, GitHub, etc. They're the most convenient ways of doing it. But in theory, you could just have some Linux machine somewhere, and you can just push and pull via SSH if you really want. So, what is the ecosystem around Git? I think I've really just covered that. So this bullet point I probably should have read first. It's this collection of websites. GitHub is obviously the biggest. It's made it extremely trivial to not only share code, but to actually contribute to open source projects, spin up your own open source project, and essentially, it's built this whole developer community. And of course, now Microsoft has purchased GitHub, so I don't know where that's going to go, but we'll see. I'm keeping an open mind at the moment.
Well, Skype put it
I mean, they obviously turned Skype into an unmitigated disaster, so who knows, right? And then the question is, how is Git workflow distributed? This is the most important part of Git, really, is this distribution, at least in terms of collaboration. So Git has this concept of remotes. So you have your local copy, and the GitHub server has its local copy. And when you clone it, you just get your own local copy. And then maybe you don't just want to use GitHub, you want to use Bitbucket as well. On your local machine, you just add that as a new remote. So now you've got the GitHub remote and you've got the Bitbucket remote. Or maybe your friend's really clever and he's got a public IP address on his laptop and he just says, yeah, just add my machine and you can push direct to my machine. You can have an infinite number of what are called remotes, which are other machines on the internet, which you can then push and pull from, providing you have permissions to them, of course. And the key question is, what is a commit? So, I think as I said earlier, a commit is essentially just a point in time. It's got a unique identifier. So in Subversion, which I don't think anyone here said they knew, but in Subversion it had a very primitive way of sort of identifying points in time. You had R1, and then the next one on top of that would be R2. So every time you made a change and then pushed it into the version control. You just incremented a digit. The problem was it's completely linear. If you've got multiple people working on things, that's not scalable. One guy might push something, make a change, but you did something while he was doing that, and now you try to put your code into the subversion server. But you can't, because you were on 5 and you just created 6, but on the server he already got in before you and created 6. So now you've got to take all your work and sort of redo it on top of what he did and then push it. But then if someone else comes in and does it again, now you've got to do it all over again, and it becomes a disaster. So Git has this concept of branching, and it's all based on these point-in-time commits, which it can merge together, and we'll cover that later.
Does the subversion use some diffing or not? I don't remember. I remember.
Yeah, you can diff between revisions, of course. Yeah, but it's very.
It was a bit faster to install because initially you just start with a current snapshot, but then as you add the commit after commit, it gets bloated every time.
Yeah, but also a subversion, you don't get the whole history. You can download it, but by default you don't get the whole thing. All right, so we're going to do Baby's first repository. Hopefully everyone's been to git-scm.com. So we're covering the command line version, but if you want to use a GUI, if you chose to install the GUI, then in the menu somewhere it will have this. But I personally prefer the console since what I'm teaching. So come on, git init. So if you're starting a new project from scratch, or you just have some code that you never bothered to version before, this initializes the repository. So you go to the folder where all your code lives, and you call git init. If it's already a Git repo, don't do this, so it will complain, because it's already a Git repo. If it's not, it's just some files and you want to start versioning them, you call this, and you are then ready to go. The next command is git add. So git add takes a list of files that you would like to add into the repository. If you want to add absolutely everything under where you're at, you can just put period at the end, git add dot, and it will chuck everything in there. Of course, if you keep your build directory and a load of other garbage in the same folder, it's going to add all that as well, and that may be not what you want. So you can also specify individual files, or you can do a directory, so you could do like src/ and then a dot, and it would add everything in the source directory. But the idea is that you git add all the files that you want, and then finally you call git commit. And then what git commit does is it'll bring up an editor window, and it'll ask you to put a short title, a nice message saying what you've done. So for your first commit, you can probably just say blah blah project initial commit. We've got a question.
Yes. How about how to prevent uploading lots of rubbish from the like compiled stuff and so on?
So the best way to do that is if you're using CLion, it should offer to add the folder to what's called a .gitignore file. So Git has knows a set of special files, and one of them is literally just the file name is dot and then gitignore, and you just have one path per line. You can even use regular expressions like star. You can use wildcards, and in anything in that .gitignore file is stuff you've told it I don't ever want to commit this. So say you have a build folder, right? cmake-build-debug. The first line in your .gitignore could just simply be cmake-build-star, and then anything starting with cmake-build is ignored by Git. The actual .gitignore file, and this is an important piece to know, should also be committed into your repo. So once you've created a .gitignore file, add it. That way, when people clone your repo, they will get the .gitignore, and their Git on their local machine is going to behave in exactly the same way as yours.
You can also use it for allow files. Despite the name gitignore, you can also give it a reverse pattern, the one which are always allowed.
You can it's files are ignored. You could do a regex match that says match everything except ignore everything except this pattern, but it's still ignoring.
The one that you put with the exclamation mark. What's checking on Stack Overflow?
It's inverse. You're using inverse string matching logic. I know what you mean, but it's stuff to ignore, but you're doing an inverse match. So you're saying ignore everything except this.
Yes.
And can you create like the gitignore? So let's say if you create like we're learning, so we're creating like lots of small projects, yes, and so we don't have to keep creating the gitignore. Is there like a way so you can create like a global gitignore for the so if you create a new project, it will be automatically applied, or
No, so I mean, because again, Git just sees what's on the file system. IDEs give you this functionality, like CLine gives you the functionality. It will offer to generate a .gitignore for the stuff it generates, and if you say yes, then it fills one in with stuff. But I mean, it just depends on your project structure, right? But yeah, in terms of the gitignore, you can do inverse string matching, and then it sort of says if anything that doesn't match a particular string will get ignored. Right, so let's talk a bit about working with GitHub for sort of real things, and then we'll get onto GitHub Classroom after. So first of all, key point: use git clone when you're dealing with an existing repo. If you already have an existing repo of the code somehow, but you happen to have, you want to just mirror it to GitHub or something, then in your existing repo you would use git remote add. You could call it GitHub, and then you would give the URL that GitHub tells you to use. By default, when you use git clone, the remote is called origin. That's just a defaulted name that Git generates for you. You could go and change it. You can use the git remote command. You can do git remote set URL or rename. So yeah, git remote rename, I believe. And you can just rename origin to anything you like. Git does not care about what that name is. It's just for you to identify what something is.
So before git remote, I should have done git init.
Either git init, or if you just had an existing repo and you wanted to poke it up to another server. So say you had it on Bitbucket, but you wanted it also to exist on GitHub or GitHub.
Okay.
Hmm?
Yeah, that I know.
It's not initializing repo, it's just grabbing something from somewhere else and sticking it on the disk. So if you're working with GitHub, if it's not your repository, so it's some third party who hasn't given you, developer access, fork it. Just a button. Go to the web page, click fork. It will take you to your own version. You can use that, and that's the one you should clone. You're right. If it's already yours, obviously this doesn't apply. You can't fork your own repos anyway. You do your work locally, so this bit is you writing code. You then do git add to add those changed files, git commit, and then git push. So I got distracted and then completely forgot to get people to do this. So what I'd like you to try is just try git initting a blank repo, create some files with some random data in it, and then let's have a go at pushing them up to GitHub. So if I can bring up my browser and it plays nice with me. You don't have to use the command line, but I'm covering the command line. There's aliases in the GUI. There's add. You'll have the same semantics. You'll have add, commit, etc. There should be an init option as well. So. So if you've got a GitHub account, which I hope you have, you can just leave it on your username. Pick a random name for your repository. You can give it a description if you want. And then you have to have a paid account set to make it private. You can optionally initialize the repository. Don't tick this in this particular example. We don't actually want to initialize the repo. The job is we're going to do that on our own machine, not to have GitHub do it first. So again, just pick a name, whatever you like. You can just go to github.com/new as long as you're logged in. So pick a random name. You can delete the repo later if you don't want to keep it. And just do not tick this box here. And I need to switch OBS because no one can see this. Okay, right. So again, just for the people watching online, go to github.com/new. Pick some name, doesn't matter what. Description if you care. Do not tick this box down here. Do not tick this.
Not so much.
Well, because if you get in it locally and then you try and push, it's just going to fail. It's already in it. You could force push technically, but no one gets that yet. So let's see, just pick something. Run uni. Pretend this is our repo. Sorry? You won't do that from GitHub. You'll do that locally on your computer. I'll just make a new repo. Okay. So you get some pretty good, concise instructions from GitHub. As you can see, oh no, go away. it's telling you the URL to use. So if you have SSH set up with an SSH key, you don't know what this is, and don't worry, you can use SSH. Or the simpler option is just use HTTPS. This option shouldn't appear unless you set it up. You should just see the HTTPS option. You can then, this is what I want you to do, is create a new repository on the command line. So don't worry about this line here. Don't do this. Skip the echo. Go straight to git init. The git add readme.md. Don't do that. Make a file of your own. Make out any file. It can be a GIF if you like, whatever. Git add that file. Do your git commit. Don't do this part. Just do git commit and see what comes up. You should get a full editor. And then finally, this is the bit I was mentioning. Git remote add. You don't have to use Origin. If you want to, you can. And then obviously this URL, which is the same as the one up here, the remote. And then finally, to put it on your GitHub, you do git push. You don't necessarily need the -u. So this option is for convenience. What it does is it sets your local master to track the master branch on GitHub. So you have a local branch called master, which you get by default when you make the commit. And then obviously once you push to GitHub, they will get their own copy of your branch called master. And this is convenient. So once you do -u once, you can from that point onwards just do git push origin from henceforth, and it would, or because it remembers this in its local cache. It tells it remember this in my local cache.
So which was the skipping?
So you do git init, you do git add, and then make up your own file. Then just do git commit. Don't bother with the message. This is a convenience wrapper, so it prevents you from seeing the editor. It literally just generates the commit with just that text in it. Whereas if you just do git commit, it brings up an editor for you to use, a text editor. The git remote add is fine. You can obviously type in your own. Don't try and use mine. You won't get access. And then obviously this git push is actually origin master. Where's my mouse gone? There it is. If you've installed Git from git-scm.com, go to your start menu. You're on Windows. There should be an option called Git Bash here, or Git Bash. You can also, or you can right-click in any folder you like, and hopefully, if you pick the right option, you can just do Git Bash here, and it opens one for you at that folder. So I want to try and demo this for you, see if we can do it. No, that's the wrong direction. No one can read that, can they? That's not very helpful. I don't know where that's gone. Oh, hello. Okay, stay in the window up. Can anyone read the text there? Is it big enough? Big enough yet? Bigger? Or good enough? Right, we're going to go with this. So, oh, this is fun. So I'm going to make a directory. That's obviously not part of Git. I'm in my folder. As you can see, there's nothing in the folder. Let's do touch. Ignore me. I don't know. So if we list the directory, you can see I've got one file called ignore me, another file called trash. So if you like to see it vertically, there you go. Ignore me and trash. Right. So the next, oh no, the hole in the window capture is not being friendly. One sec. capture, window capture, that one, and where are you? Terminal, cool. Okay, there we go. Right, so we've got our files, let's get in it. And we've got an empty repository. So if anyone's wondering, by the way, let's do the regular list. So if anyone's wondering, my shell, I use ZSH. It conveniently has some extensions that will integrate with Git and show me my repository state. So this is all custom, it's not part of Git. But as you can see, I've now got a master branch since I git initted, and I've got some untracked files. So I'm going to add trash. So I do git add trash. And now that's added. And then what I'm going to do is I'm going to make a .gitignore. And we're going to just put ignore me in there. Now, if I try to add ignore me, it should complain. Yep, so because my .gitignore file is set to ignore that, it won't actually do it. You can use -F to force it, but that's a bit silly, obviously. Now I want to add the .gitignore. Is everyone keeping up so far? Not at all. Why did you don't clone? So oh no, it cleared it. Alright, let me restart. Let's start from below. Okay, right. Starting from the beginning, I've got a folder, yeah? I call git init, and we've initialized our repository. Is that good so far? Be in a folder and call git init. No, you just go into put your terminal in the folder that you want to actually do the repo at. Yeah, so you change directory to where you want to go. So in my case, I'm in temp trash. Is everyone there on this bit? Open a terminal at some folder you want to work in, an empty folder, and then run git init. And git init should say something similar to this. You should have as you can see, it's in my actual. That's the path there, like it's my home folder, right? I call it temp trash. Anyone still need time? All good? Okay. So then we want to add my files that I created. You can create these however you want. You can create new file in your Windows Explorer or Mac Finder or whatever you use. But I'm going to add trash, so I call git add trash. And then my magical console has a little thing that shows me it's added. To check on it, you can do git status, which shows you what you've actually done so far, where you're at. This is git status. So it says we're on master. There are no commits yet, which is obvious because we just created the damn thing. I have one file that I'm going to commit, and I currently have 2 files that Git doesn't care about because I haven't told it to do anything with them. So I'm actually going to get rid of that one that's garbage because that's my editor being silly. So ignore that one, not interesting. But we've added a file. So is everyone... No, there's nothing to claim.
Oh, you just
yeah.
Because what we do is, if you need to add anything,
You should, if you create an empty repo in GitHub, there shouldn't be any way for you to clone. You should never have been able to clone anything because it would have been empty. So unless you tick that box that I said don't tick, then shouldn't have been able to clone anything. It should just be a fresh repo. Alright, so assuming everyone's followed this, so we add a file, I called it trash, you can call yours what you want. But that's now there, ready to go. If you're on Windows, maybe you prefer to do trash.txt or whatever.txt. Now I'm going to do a .gitignore so that I can actually ignore the ignore me file, so I'm just going to use Vim as my text editor. Let's see, .gitignore. And I'm just going to put ignore me in the file. Okay, seems straightforward enough.
Did you have the trash file?
I made it. I just did touch trash to create a file. You could use Notepad to do it if you want. It doesn't have to be called trash. Call it what you want.
No.
You can get in it in an empty folder. There doesn't need to be any pre-existing files. You can only add files that do exist. Right. So I've obviously done the git add. So now if I do git status, we can see that. Oh, let's create that stupid file again. Right. So you can see that I've got trash, and now the ignore me file doesn't show up in the untracked files. So untracked files are files that Git doesn't care about until you tell it to. If you add them, it will start caring about them, but until they're added, it doesn't care. So we're going to add the .git ignore. Cool. So now I've got that, and now everything looks good. It's going to add 2 files. But if we look in the folder structure, we've actually got, it does exist, but it doesn't say anything about it because this magic file said to ignore it. Okay, so now we're going to commit. Everyone keeping up? How far back do I need to go?
How are you getting on? Anybody behind? Somebody? If you need help, just lift your hand. And there is Christian, Jacob. The more experienced people can just,
Yeah.
get to you and
If we don't know where you're at, we can't really do much, but we can come over and help you, no problem. Anyone want help? Okay, alright, let's carry on. So, we're going to git commit. In my case, I get Vim, lovely editor. If you don't like Vim, you can customize what it uses. I think on Windows it might use Notepad.
How do you insert? How do you get out and insert from Vim?
Press escape. So we do my first commit. Committed some stuff. Okay. And we have a commit. So then the last piece of this, of course, is to add the remote. So I'm going to shrink this down slightly if I don't cut it off. Interesting, that doesn't move. Right, so git remote add origin. I'm going to call it origin. In fact, no, I'll call it GitHub because I like that. And then I'm going to grab my SSH link because I have SSH set up as it happens. And then I'm going to paste it in, and then that's done. So Git has this concept of remotes, right? They're remote servers or machines that you can send code to and grab code from. Right? So if I do is it -v? That now lists, as you can see, I've got my GitHub remote, and there's two. These are the same thing. There's one. You can have one URL for fetching, and one which is when you want to download, and then you can have one URL for pushing, which is upload.
So you reserve that space on the server.
No, you just send data to GitHub. They take care of the storage.
That's the address.
Yeah.
The address you sent it to.
No, this is a URL. It happens to be an SSH URL. You don't have to use SSH. You can use HTTPS, and it uses this. The URL isn't important.
That's where your project's stored.
That's the URL that GitHub give you for accessing, download, and upload. Yeah. So.
Because I've added test file.
Mm-hmm.
Git status, no commit yet.
You need to call git commit. When you do git, so one key point is when you call git add, that goes to a sort of special staging location. It means I would like to do something with this and put it in a commit later. So you first sort of tell Git, please gather up all these files into a staging area. And then so you'll call git add for whatever it is. And then finally, when you've added all the files you want to actually put in a commit, you then call commit. And then you put a message in there to explain what the commit was, like, you know, fixed a bug, added a feature, whatever it is. And then once you've done that, the commit now exists. You can't, when you git add, you can't send the staging area to a remote server, but you can send commits to a remote server. Anyway, so yeah, this is the remote. These should almost always be the same, unless you're doing something really funky. These would always be the same. So now we push it. Let's see if this fails because my key's not on here. I hope it is. I called it GitHub. So we're going to push master to GitHub. Yeah, okay. Alright, so you shouldn't see this. I could use HTTPS, but my damn Mac doesn't have the key. But this is the last thing you need to do. So you'll do git push GitHub master. And then if you refresh the page, I'm going to pretend that I've done this on another one. If you were to refresh the page, come on, why is the internet so slow? Oh, something I did, this will work. So then you'd end up with something like this, where you've actually got some real files to stare at.
Question, if you have multiple remotes, there is any way, practical way to keep them all synchronized? All different remotes.
I mean, yeah, you could write a bash script. However, there might. Where's my mouse going? Come on. Git might have support for that these days. Let's see. So Git can help you with pretty much anything. So, for example, to answer your question, we can do git push help, and we get a nice list. And let's see what options have we got. Yeah, I suspect that's the one.
Yeah, I know about the documentation, but usually it's not
push.
super fast.
Actually, no, it doesn't do quite what you think. That will just push to one remote, but it pushes all of the branches you have. So it's not quite it. You could write a bash script that loops over all the remotes technically and do it that way. But there may be something. Where's the black pen? So the key points aren't here. Points in time, so you have 5 minutes. So that's a commit object, right? And that's a point in time, so that's like, you know, so you do that, and then that'll go to. That's another point in time. Three, and so
You need to go and insert more if you want to type something. You press insert. You press insert. Insert. Then you press the key insert.
So git push is just another thing. So now if there's a file that you want it to be why now go first of all sort of arrange your collage with files and then you take a snapshot and set that up.
Okay, so this is like
Yeah, so git add is the way to create this collage file. Git commit, snapshots it. Git push, then uploads the snapshots for the history.
see that. It's like second test. This one.
You press basketball
Look at it.
Once you've committed it, that commit object, that snapshot can go up.
Try and push it. What's the
Push
step?
push it.
This is a really good tool for flow. Use GitHub where I'm now.
Standard text file, and each line is some part of the
Tool,
style of the entity. Like the first line on the say let's line 1, style 2, line 2, style things is it will look back and say okay, line 2
it's hard to, I think it's hard to build a mental model by takes time to build a mental model of what you're actually doing with Git, which is why I posted this on Slack. This is actually quite a good voice game. Git for ages so long videos, like 4 tutorials.
So what you gave it with something.
More on my readers all the time. Yeah, but it's just that last week when just updated C++, you don't use Git and GitHub push and what I'm missing is that's work. So that's two. No, I think we've got two, so that's good. Second, first, second. Yeah, I've been coming to this. I have come to every session. Yeah. What do you mean? Oh, code along. Yes, I haven't. So yeah, I've done some coding on my own. I haven't actually built just so it's interesting as a programmer who comes from different languages. It's interesting closer to the hardware, you have to think a lot more about what you're doing when you're doing something with start basics. We don't really consider it directly. I haven't really I just want something to do much at home. I keep sort of, to make the time for it. It's frustrating. It's just so much. Oh, I get frustrated though. I get frustrated. Yeah. Yeah, so it depends on what's yeah, like I've been, I really want to improve my maths, so I think on this as well. Because I suck at it's a subscription site that you can sign up for it for free and get email challenges every day. Potentially, I think it's not massively better at school at the moment, but I think getting better at maths. I suck at maths, but I got better at maths since I started to program. Because you're training your brain to do kind of the same thing on a different theme, right? So, but the principles are very similar. Yeah, it's pretty good. Yeah, brilliant.org. Yeah. It's better than Khan Academy anyway. I tried Khan Academy, which is really good. I reckon this is better. Yeah, that's it. Yeah. Yeah, program.
Does the gig thing
I like it really
The problem is for some reason I just ended up getting really frustrated with myself. I would get like physically angry at my homework. Yeah.
I studied South Korea, and then I moved to the States, and then I was like, I could do anything like that, like 12, and then with that knowledge, I graduated like, I was like,
Oh wow.
so like, I moved to South Korea.
You need more time?
Yeah, so you have this. So you
Okay.
I think Agatha, which was my classmate in school, her mother was pretty well connected, so she got a scholarship. She spent the fourth year of high school in the US. Apparently she got like the top mathematics grade and she did everything. She came back and she was unable to pass.
Wow.
Yeah. But at least she was in California, I don't know very well, but she was doing even mathematics and then there was multiple stuff like that. And usually there is the writer apply, a senior one apply, and who applies with a completely idiotic. So even if you do random and more or less, but she did it on top of everything, like what is the Sino's position.
All right, 3 more minutes, folks.
I mean, the derivative was one variable of something. So you can do derivatives with multiple variables, but only one should go.
Yeah, really good.
Yeah, usually we do.
I'm gonna grab a coffee.
I was frustrated with like every question I have.
All right, 1 minute, 1 minute. Okay, right. So hopefully everyone sort of got the gist of this workflow, which is that you will have your repo either by initializing it or by cloning it, in this case initializing. Cloning is arguably simpler because you don't have to stage and do anything, you've got stuff to work with already. But you know, the cycle is simple, right? You do some work, change some files, add code, remove code, make new files, delete files. You use git add to add those files, or if you delete files, you use git rm, remove, very simple. You use git commit to create the snapshot. So git add is like your collage of what you want to commit. And then when you call commit, it then snapshots it. And then the snapshots are what you can upload to other people. You can't this stage is local to you only. This stage, once it's committed, can be pushed, uploaded to wherever you like, GitHub, etc. And the cycle repeats, right? So you commit, push, do some more work, add, commit, push, do some more work, add, commit, push. Okay. So then the next part is creating merge requests. So this is actually fairly simple. Once you've pushed it to your repo, go to the website. If it's from somebody else's repo, so if in this case you initialize, it's yours only, yours alone. But if you said you wanted to clone, don't actually do this because it's a bad idea. The Linux kernel guys won't accept this. But in theory, you forked the Linux kernel, okay, and then you downloaded it via git clone, and then you did this, you know, do some work, add, commit, push. You just go to your clone, you go to your fork on GitHub, just click the make merge request button, and Git pretty much just figures it out like, yeah, this is the work I did, I'd like to put it here, please, submit, and then somebody should come along and go, yep, cool, we're taking that code, it's great, or this is garbage, go away. One of the two.
Is it normally good practice, or is it normally not good practice, but convention with because with repos that you work on yourself or with friends or with a company, you'd normally work all on the same repo, and you would all clone the repo, and you would all push and make pull requests directly to the repo. But with, say, open source projects, is it considered better to do forking and then merging from
You have to.
fork?
So essentially, when you're working on open source stuff, right, you're some random guy on the internet. GitHub is not going to give you the ability to change the code in that project's repo, because you could introduce very nasty, malicious code. Instead, you
have to make a pull
fork. So the difference, the difference between pull request or merge requests, they call them pull requests, yeah. Like GitLab calls it a merge request, I call it a merge request. You want to merge something, it's just semantics, they do the same exact thing. The only difference is that because you're an outsider, you're not just making a branch inside the same repo, right? The semantics are pretty much the same from your perspective. You do some work, and then you want to get it into their code base, right, into their master, yeah? So typically you use master as the sort of canonical release branch. So if you did have access to the repo, so say you were a team working for a company, you just skip the step of making a separate repo that's yours. You just make your own branch on that repo.
Mm-hmm.
So you just have a different branch name. So instead of master, call it like my fantastic feature. And you'll send it up to that instead. And then someone comes along with Visual Code and says, okay, can go into master. It's essentially the same process. GitHub just has this way of doing separate repos for security. And they take care of all of that, you know, separate repo stuff for you. And yeah, just, you know, pray that once you've actually done it, they say, yeah, we'll take it. Perfect. So, working with GitHub Classroom, because this is the one that we're going to use with you folks. This is the one that's most relevant. It's a much simpler workflow. Hopefully those of you who tried it last week might remember this. You just click a link that we give you, or type it out manually from the slides, and then you just, GitHub does a little bit of processing, and then it just takes you to a page which will have a repo you can clone. We will pretty much always start you off with some starter code or instructions that you can just clone and work on. And that's it. You don't have to fork. You don't have to do anything complex. You just use the link we give you. Everything's done for you. You just clone it, go. And you do that standard workflow. Do the work, git add, git commit, git push.
So each one of us has a different repo.
When you click the link, GitHub will then all automatically for you create a repo that's unique to you. You have the ability to push to it. You don't have to do anything.
Again, a question because I was interested in the tool. Can you also set it so that has some randomness or some, I don't know, for example, the repository that I get will have different data from the one that Alex gets and so on?
No.
They're all the same.
If you use unless I gave you a different link to him, you're going to get the same thing.
Okay.
Each link goes back to the same exact starter data that we generate. So we'd have to give out separate links basically if you want to do that. But we could.
If you can set it with some parameters.
No, we just make, what we would do is we would have to make separate assignments and then individually give you a piece of paper or something. So for live exercises, you can just push code as often as you like. Our dashboard shows us what you've done, so we just see it. You don't have to do anything complicated. Again, please try to avoid adding junk. So make use of CLion's ignore, auto-generate git ignore feature, because we don't want the whole sort of built application and all of the intermediate binary output lobbed in there with the source code. I'd rather just have the source code only. And you can obviously just do that yourself. Usually we'll give you a few files to work with. You can just specifically git add those if you're not sure. And yeah, if you did only modify existing source files, then you can also use this handy dandy feature called git add-use, which stands for update. So what it does is any files that were previously added into Git, into your Git repo, if they have changed, it will stage them for committing. So if there's any new files, like garbage that you compiled, the compiler output, because they weren't tracked yet, they will be excluded, and it will only update the ones that are the source code, because the source code was already tracked.
You can also jump to the commit if you want to do that unless I'm misunderstanding, because you can just do git commit -a, right? And then you don't have to do add first or just.
I don't know off the top of my head, but that does sound correct.
You can do git commit
yeah. Also, I would argue in favour of doing this instead, because you can then run git status and make sure it's looking kosher.
Yeah.
And if it's homework, then we'll generally review your repos in the next session. So we actually had a few, but if time allows, we'll go over them. Okay, so on to the concept of branching in a bit more detail. First of all, what is a branch? Any ideas?
It's a different version of your work that you're working when you're developing a feature and a fixer.
It is, but I'm going to draw it out. So it's actually what we call pointers, right? A branch is actually a pointer. A branch is a pointer. So within Git's concept, right? Imagine I've got my commit 1, commit 2. Let's just do commit 3 for the sake of it. Right. So we've got some history of work, right? Okay. We've done commit on day 1. On day 2, on day 3. These are all snapshots, points in time, the code we've done. What's in them? That's not important. But we want the concept of sort of pointing to a specific piece of history. So this can be, I'll make a point called master. So we have a branch called master. The master points to commit 3. And then maybe I want to work on a feature. So we'll end up sort of, I can end up checking out to a new branch. So we'll make one called feature. I got a feature branch, and we will sort of initially we'll go here. So we're now tracking feature branch because we've moved off of master and get feedback where it is. And label branches are effectively just labels and it's called feature branch. And then we make our commit. So we end up with commit 4. So we've got another commit now. And when we make that commit, it very kindly updates the pointer for us. So the pointer no longer points to commit 3, it updates it and points it to this new commit 4. So now that's still there. Master is still pointing to commit 3. That hasn't moved. I can check out mastering, I'll go backwards in time to this snapshot. And then I can check out feature branch again, I'll go forwards in time. And so that's it in a nutshell. It's just a label that points to one of the factors.
Just a question. Are there the multiple copies of the files per commit, for each commit?
No, Git is very efficient internally. It implements a load of smart deltering to make sure that you don't end up using up a crap ton of space. So no, you don't have to worry about that. No. So consequently, I can I can create a ton of different labels and make them all point to commit 3. You can even make empty commits. I can make 100 commits, right? On top of this one, that don't actually change any files. You can do git commit -- empty, and it will just make a commit where you can put some message in it, but it won't actually have any changed files if you wish to do that. So the question is why a branch is useful. So now we are going to get it. So let's take this idea. Right? We've got our feature branch. So I've now made my Q4. The released software is still building off of this. So people are all taking this code and working on it. And then I want to get my feature branch in. So I'll push this to the server, and I'll push these pointers as well. And so then I'll make the merge request. It says I would like to merge feature branch into master. So really what it's saying is that it would like master to have its pointer updated to. And then when someone accepts it, that's what happens. It just takes this and we're not pointing here anymore. Master's going here as well. So now you still have feature branch unless you get told it to delete it. You can delete branch. Otherwise, you now have 2 pointers for those pointers. That's the other. We'll do that in the other, doing branching now. So the question is, what are the caveats of branching? How can it go wrong? If you use it properly, it really arguably shouldn't. As long as everyone on your team is well behaved and they work on their own, they come up with their own branch labels. So if you have a ticketing system, you start off with branch labels. Something unique, right? And the idea is that nobody ever just pushes stuff to master without going through a review process. Now, one of the things that can happen is you can get conflicts. So imagine we have a linear history. So we're going to say that square boxes represent commits, right? So we're going to have, 1, 2, and then developer A goes off and he works on one feature, and then another developer goes off and he works on another feature. So now you've got diverging histories. So these need to be reconciled somehow, right? So imagine master is pointing here. So the master branch. So then, obviously, you're not just going to merge them both simultaneously.
Sorry,
Technically,
okay.
so this is developer A, this is developer B. So let's say developer A gets his merged in first. So, well, we update the pointer. So I'm going to read that. Oh, this pen is not good. This isn't. Okay. So is this? No, it's just whiteboard mark. So master's now pointing to here. Oh, lovely. So we've got master pointing here. So now we want to get this in. Developer B wants to get his in. Well, we can't update master pointer here because it's going to disappear. This doesn't have that change. So Git's very clever. What it does is it analyzes all the changes in this commit object here and generates a new one. So we get a new commit object here, and each commit has a parent, right? So this is the first commit, so this one doesn't have a parent. This one does have a parent. It says that my parent is this guy, and then this one would say my parent is this guy. And this one would also say my parent is this guy. This one is special. It's a merge. So it says it has more than one parent. A commit can have as many parents as it wants. Basically what it does, it says parent 1, parent 2.
Ollie, are you just trying to make it more to the side?
I'm drawing it, by the way. So we've got parent 1 and parent 2 in what is now called a merge commit. And one of two things will happen. If the change is made here did not in any way mess or touch changes made here, so it didn't change the same lines of the file, then Git will just happily go, yep, that's cool, we'll accept those changes, and we'll generate this commit made out of both of those changes, and then all we have to do is just update the pointer again, and now master points to this commit here. Cool, simple. And if there is a conflict, well, you have to just fix up the file. It will show you, like, well, this commit changed lines 3, 4, 5, and this also changed lines 3, 4, 5. Here's what this one did to 3, 4, 5. Here's what this one did to 3, 4, 5. Please go and make the file look the way you'd like it to look. It works. And then once you've done that, you just give it git add to say I'm happy with it, and you get this anyway. And now, hurrah, hurrah, our master's updated to this new version. So how does branching scale with team growth? Okay, so this is where we are getting a little bit more interesting. So, on most standard teams, unless you're working with a silly number of people, which you shouldn't be, then the recommended flows, you have a master branch, as it's called, and everyone will fly off, they'll work on feature branches, and then they'll submit the merging, and someone accepts it. Now, one of the things that you need to ensure you do is never rewrite the history of shared branches, ones that are not your personal playground. So treat master, for example, as one that you can't rewrite the history of. Okay, history rewriting, let's get to that. So you have this series of commits, right, over touch points of time. There's a few complex commands you can do to reorder. So I can rewrite history and say that actually this wasn't the first commit, this would be the first commit, and that's through Git rebasing. Probably a more simple way of messing things up is that, let's imagine for a second that we have our history here, so we've got commits 1, 2, and this is what's on the server here. And then developer A comes and makes another commit and puts it on master. But then developer B also makes a commit. And this team doesn't care about merge requests, they just want to get stuff in. So, developer A managed to just push to master, and this became the point of the master, that's cool. But then, developer B comes along and tries to push. Well, the history, master's pointing to here, right? It's not pointing over here, there's no Git will refuse to accept his push. The server will refuse his push, because in order to push to a branch, in order to update the pointer, the update must be on top of wherever it was. So it must be an evolution. It can't be going off elsewhere. So for example, if developer A then grabs this and he makes a new one on top of this, that's fine. But this is not part of this history. It's divergent, so it will refuse it. And there's a wonderful command you can use called git push -f, which just says, I don't care, accept this. And then all of a sudden, developer A is going to get very annoyed because developer B just said, no, this is gone. We're now just pointing over here. And this never existed. So, following the merge request model is where I say this, people can't do stuff like this. But there's ways to recover from this stuff, which we'll get into a bit later. But don't annoy your team. Don't force push to branches that are not your own. You will annoy people. Okay, so git rebase is a way of replaying of changes. So imagine we have, again we do the commits model, we've got 2 commits, yeah? We've got, and this is master, right? Yeah, so master points over. And then someone comes along, they get a merge request in, and then another commit comes on top, right? And so now Coolio, master is going to point to here. Yeah. Meanwhile, though, you were working on a feature, right? So you didn't know, you didn't see this. You just were at this point in time, and so you went off and you did some stuff, right? So now you've done some work here, right? Well, in order to keep a nice linear history, you decide that actually this can just be replayed on top of here. So when you call git rebase, right, what it does is it will, you can do git pull that rebase actually if you want to grab, to download and then do it for you. What it does is it will unlink these two changes and just treat them as logical differences. And then it will take this one and it will essentially replay these like a sort of record. So imagine each point in time contains some changes since the previous. It takes those logical changes and you sort of replace them on top. So now, instead of the parent of this guy being this commit, it's now this commit. So because that's now a linear history, that can just push straight onto the master, no problem. You don't have to have a merge commit, so just fast forward.
So a commit is a set of changes. Set of new lines.
Added lines or deleted lines or files. Well, it's a snapshot. And there's obviously, that snapshot has a difference compared to what its parent is, right? And that can be expressed as lines changed, binary files added, binary files deleted. So if it's human readable files like source code, it has strategies for then attempting to combine them in a way that's not conflicting. If it's binary files, it can't handle those at all. It's designed for source code. So to actually check out a branch, super duper simple, git checkout, -b, and the name of the branch you'd like to create. If you don't specify -b, that means you want to move to an existing branch. So for example, if I did this, I want to go back to master, I just do git checkout master. Flip me back to the master pointer. The pointer for master. Did that do anything? That's weird. Okay, so what do we do in disaster strikes? Oh no, I deleted a file. Call me. Oh. Well, actually, it's not so bad. Unless you did that. And then you probably have made a lot of people really, really, really angry. So, fortunately, there are solutions. So, deleting your own work. If you nuked your entire Git repo by literally moving it to the trash and then emptying the trash, unfortunately, you're going to need a file recovery program. That one's pretty much fatal. That's why you should always push it to a remote server. You can just clone it again and you've got it back. If you manage to delete everyone else's work, where I was talking about earlier with the forced push, then that's okay. You go to your annoyed colleague and have them do the same back to you. Forced push. And then you can do the right thing, and you can actually merge your code in instead. But if you've just done something see like a new plane through. What's a good example of this? You just delete the file off the hard drive. Right, the file was in Git. You put the file in Git, and then you accidentally delete it off the hard drive. No problem. You can just do git checkout -- path to that delete file, and Git will pull it out of the most recent commit you made. Easy. Or we can give it a folder and do dot, and it'll check out everything in that folder. Technically, you can also use git reset, but in my next bullet point, oh no, so it's git push. Yeah, git push -- is bad. You could use git reset, but be wary of it. Let's say you do 1,000 lines worth of changes, and then you've got one file that you actually didn't want to change. Technically, you can do git reset -- hard, and what that does is it will just reset everything. However, that means that not only will it reset that file you want to get rid of, it's going to kill off that 1,000 line change that you really want to keep. So, if in doubt, use git checkout.
You get everything to the previous comment unless you pass an extra comment. By default, he resets everything to the last to the previous comment.
To your head, as it's called.
Yeah.
To the head pointer.
Unless you pass the hash of another comment.
The hash of another commit, tag, or another branch. Any of those work. Yeah. So commits in Git are identified by what's called a hash. Just consider it to be a unique identifier for that particular commit. But yeah, absolutely take care of git push -f. Also, I made these slides a year ago, and these bits are ridiculous. I don't know what's going on with them. They're just stock images that Google gave me. Yeah. I mean, that is like, why is it sideways? What is going on? They don't look happy though. They definitely don't look happy. That guy looks like someone pushed over his code.
Yeah.
That's so.
Half of them. After doing the push up.
I mean, I'd be pretty annoyed about being sideways anyway. But, so yeah, take care with git push -f. Generally speaking, if you explicitly put a branch after it, which is yours, then yeah, okay, fine. You might have rebased. That's fine. You have to force push. If you rebase your changes, you have to force push. But don't do it to master. And today, it's not that big of a deal. Sites like GitHub give you ways of protecting branches that matter, so you can set master to be protected, and then it will not allow you to just rewrite the history of that branch. It will do a check first. So, this is wonderful. Git reflog. Git reflog. So, I had a demo for this last time I did it. I want to see if I can dig it out. But, where are we? This is the problems of having a new Mac. You tend to lose a bit of stuff. So, reflog. So git log and git reflog are completely separate. Git log is just your history. So you can see I've got one commit, I did some stuff, cool, yeah, right. Git reflog, on the other hand, is not quite the same. This is actually all the activity you've done in the repo. It can be anything. It could be committing, it could be rebasing, it could be resetting. Git just stores commit hashes to stuff. So I'm going to try and demo this, just to show you how it can save you. So let's say I make a commit, right? Let's say echo okay. So you can see now I've got 2 commits, yeah? I just added a new one with that wonderfully important file I just added. Well, now let's say that I go to a new branch, so I'll do git checkout feature. And then we'll pretend I went and worked on a feature. And then I wanted to get rid of the feature branch, but instead of getting rid of the feature branch, I decided, I accidentally, sorry, just deleted master. Oops, not very clever, is it? Git reflog will save me. Technically speaking, you don't even need to go to reflog because it told you right there what it was, but for argument's sake. So we can see that our history was that I checked out, I moved from master to feature, and that left me on F5. And then I did my file commit here. So we know it's F5. So what we can do is we can just restore the branch. So I do git branch master, and master was at F5E 5D 9, and I can go back to master now. It's undeleted. Hurrah! Everything looks good. Marvelous. One of the things that you can't save yourself from though is if I did something like this. So I have, what files have I got in here? So if we do echo little stuff, my file. So I do git status, you can see I've modified it. And you can even see I've added the line more stuff. This is nuclear. That's gone. You're not getting that back. That's it. So careful about using reset with work you've got. Usually the safest. No, this only applies to tracked files. If it's an untracked file, you're safe. So the one you're thinking of is git clean.
You can do that from the machine of someone you want to do.
So git clean is also nuclear. So if I git status, for example, right, it's all clean. I can do, let's make a file called that. Right, so we've got lsj, yeah, whatever. If I do git clean, gone, nuclear, no way of fixing that. So use git reset and git clean carefully. Maybe the safest way to do this kind of stuff is just make a branch. Go and make a BS branch called whatever. Just commit everything to it, and then go back and clean up as much as you like. And then if you're happy that you didn't screw it up, you can delete that branch. So let's say we're experimenting, right? I'll do let's make a new file again, whatever. So we've added the file. Yeah. Oh, yeah, technically you can. Depends on their file, on their operating system. Like, so, oh, has anyone got a Mac charger down to 12%?
No, I mean, not the OS, but Git itself. Doesn't it have a permission system?
That's no good. That's no good. Say that again, sorry?
Doesn't Git itself have a permission system?
I mean, it does in terms of the servers. So you can obviously say you're allowed to access it or you're not. But anyone can control their own laptop. Okay. Say you're on Linux. You've got like owner permissions, group permissions, other permissions, right? Yes, Git can preserve those for Linux, and they kind of sort of work in Windows. So you can definitely make files read only in Git when they clone it, but it's their computer. They can just change the permissions. So yes, you can, but it's futile. So anyway, yeah, back to this before I run out of battery. So we're going to commit this. I happen to have abbreviations, which I'm going to start using. So, ta-da, but that's the permissions we're talking about. So that's like read write owner, read group, read other. But now if we look in the log, sure enough, yeah, cool, we've got that commit. Okay, lovely. And then let's say that we're going to check out to another branch. So again, I have an abbreviation. This is just git checkout -b. Okay, great. We're on new branch. Cool. Which just points to the same place. And then let's say we do some more stuff. So what should we do? This. Added it. In the log, we've added some stuff. Right. So at this point, I can go to master, and now commit's gone. You can look at the ref log, and you can see that new branch was created here, and I can safely delete new branch, and I'd still be able to see this history in the log. But the point is, if you want to then start nuking files or whatever, right? So let's go back to our play around one. What was it called? New branch. Right. Then, I can start removing files safely. And because I'm on the new branch, which has all the garbage in it, it doesn't matter. I've got a way of getting back to it. So that was the only point. That was the main point. Yeah. If you get ZSH and then own my ZSH, it gives you these. Also, does anybody have a Mac charger? I'm about to save me. Save me. Right. Sorry? Yeah, they're just aliases I set up in my shell. They're not part of Git. Which one? Oh, you want to read my aliases? I'll build. No, I don't know. There's a load of crap in there from OMyZSH, but I can probably do this for you. Hold on. They're generated by OMyZSH if you're interested. None. Cool. That's really useful, isn't it? Yeah, it's alias, isn't it? So it has these are all from OMyZSH. If you want to use the shell, there's a ton of them that it generates for you. Like some of them are sort of like git describe tags. I don't use half of these, I think, but some of them are quite nice. Like GLGs. Yeah.
I mean, if you want, or can you share that on GitHub?
What?
The shortcut, like,
Just get OMyZSH.
Oh.
So there's something called OMyZSH, but you have to use ZSH, not Bash. And then you just download and install it. It's got instructions, and it gives you all that stuff for free. All right, back to the presentation then. So, oh crap, where's the mouse gone? Yeah, so as you can see, git reset -- hard sounds scary, and frankly, it can be quite damaging. So be careful with that one. If you happen to have accumulated stuff you don't care about, then you can just run it, and it will nuke everything, but it's not recoverable.
You said it was to do with that it works with track files, but when you demonstrated it, you haven't made any commits beforehand, so I didn't quite understand.
So what it does is git reset -- hard will reset the state of any track files to what they are in your latest commit. So if you've made changes on top of a file that is tracked, and you have not committed them, those changes will be blown away. It resets you to the latest commit.
So how does it differ from making changes to files and then just checking out those changes? So I can make changes to files, and then if I think I need to go back to my latest commit, I'll just do git checkout dot, and then I'll be back at my last commit.
So if you have changes pending that you haven't staged, you can't check out to another branch. You have to either commit those changes or get rid of those changes.
No, I'm not saying check out to another branch. I can actually check out the files.
Oh, yes, you can individually. Yes.
Check out dot.
Yes.
And then that just checks out because I haven't done git add.
That will also blow them away in the same manner.
Nah, I can't. So is it the same?
Check out also changes the head or not?
Sorry?
Git reset add also changes the head. Also doing git checkout, does it?
So if you don't pass a commit hash or something off a hard, it's just going to use head, which is where you're currently at. But it's going to blow away any changes you didn't yet commit, including ones you've staged. If you did git add and then you do git reset, they're gone.
Git reset add the changes the head, but also git checkout does it?
So git checkout would undo what's on the file system, but it won't undo stuff you've added. Git reset will not only nuke the stuff on the file system, but also nuke what you added.
Yeah. So if I haven't added and I want to get rid of my changes, I just use say git checkout dot, and if I
As long as
added stuff,
those changes, the stuff that's added will still be preserved, and you can still commit it. But you're now in an interesting situation where it's on the file system doesn't actually match what's ready to be committed.
What do you mean if I've never had that before?
The staging area is not what's on the file system, right? So your workflow is that you make a change with Notepad or whatever, yeah? You git add it, and then you do git checkout on those very same files. So now, on the file system, they are just whatever they were pre-changed before you changed them.
No, I was talking about because I would only do git checkout dot, and that would automatically check out all of the changes that I made to the untracked files, right? So I'm just saying.
No, untracked files are not tracked. Git checkout can't possibly do anything to untrack files.
Well, so the sorry, the files that, or the files that I haven't been, the files that I haven't added.
The changes that added to track.
Changes that I haven't added.
If you stage them, then they're safe. If you did not stage them, yes, you delete them. If you add them, they're safe. So. Go through branch again, sorry.
Or you can do Atlassian or Raspberry Pi. We have a pretty good guide. I don't remember it all, but when I use this, it's slightly different.
You in this? Oh, if you want to go over it again, we can do. That's fine. We can cover branching again. Okay, but I think maybe at the end there's questions. So ref specs, referencing specification essentially. This is a very complex sounding word. I don't like it, but I'm going to sort of try and help you understand how it implements this logic to understand what it's doing. Right. So let's take a fairly sort of simple-ish command and do git push origin master. So our ref spec is actually abbreviated to just master here. So we're saying we want to push our version of master to origin. This is actually a specification, so there's a colon separator that separates your side from their side. So this expands, Git expands this for you, but this is actually effectively master colon. So it's saying that I just want the name to be the same on both sides. So my local master, push it up to it, and it to know it as master as well. You can change this. If you change the other side to something else, you could have, you know, master colon thing. If you did this, you went to GitHub. So you did git push origin master colon thing. And then you go to GitHub. GitHub will say that you push the branch to the thing. Locally, you don't have a branch to the thing, unless you create one at an early time. You don't have one, it's all the same master. You told GitHub yeah. Then you can get more complicated. So say we've got two remotes. We've actually got Origin and we've got GitLab instead of GitHub. Okay, so we've got GitLab as a remote and we've got Origin. So they're just two different remotes. So now we can get more complex. Let's say we did download from GitLab. We've got some branch called I don't want to have to check it out locally just to send it over to GitHub, right? I just want to get it off of GitHub. So we can do a more complex spec. We could do git lab / feature colon. This is representing our copy of the stuff from GitLab. Name of the branch. It's inside GitLab. It's not local. When you don't specify a remote here, the slash means it's whatever you actually have locally. This is obviously sort of stored on your hard drive. It's stored in a kind of folder. So we're saying that I want to take what I grabbed off of GitLab, stored in the GitLab sort of internal folder, and branch the feature. I want to put it on GitHub, so GitHub happens to be Origin. Actually, no, sorry, don't use the Origin because it's foreign Origin now. And then we can just call it feature. And that's essentially the ref spec. And you can use this in other ways. So I can do git checkout with that feature. And it'll just check it out. It won't create a local branch for the feature. And this is actually when you do git checkout some branch name. Git goes and looks through your remote, so it looks through branches that exist on Origin. So you grab all the latest stuff from GitHub, and someone made a new branch on GitHub. So you do, they call it John's branch. So you do git checkout John's branch. What you're actually doing is doing git checkout Origin / John's branch. Sorry, that's not what you're doing. Is creating a new branch with John's branch locally, and then setting it to point to Origin / John's branch. If you have Git figures all that out for you, it's just plus sugar. It goes, okay, you do git checkout John's branch. Let's have a look. Yep, there's John's branch. Okay, cool. Let's make a local one, make it point there. It just does, it's all sugar at some point, so yeah, but internally to Git, this is best practice. And you can check out tags. You can look at the Git log, see there's long hashes, you can check out a hash. If you're not on a branch anymore, it's not very useful. You could obviously commit on top of it. You probably want a pointer to it so you can easily find it later. Anything that's not pointed to by a branch can be garbage collected. So for example, I have my master and it's pointing to commit 4. And then so I reset it to point 3 and I delete each branch and then nothing's pointing to 4 anymore. After a week, and if you call the garbage collection into Git, or eventually it will classically it will destroy that commit in its state. You get about a week's grace. If you make a branch point to it again, it won't get collected. So then there needs to be a pointer to a commit in order for it not to get garbage collected. Alright, so let's have a little bit of a look inside Git. Git log we've basically already covered. In fact, I think I might have got through most of this already. Is everyone clear on what Git log does? Well, just to recap, I'll tell you anyway. So obviously Git log just shows you the history of wherever you're at. So you check out to a branch or even to a commit or a tag, and then Git log will show you the commit you're pointing at and everything that's older than it. If you then check out to somewhere in the future, you'll see that and all of its parents, which will probably include the stuff you were looking at previously. Simple enough. Git status shows you 3 core pieces you can make. 1, what branch you're on. So it's more than 3. But 1, the branch you're actually on. It then shows you stuff in the special staging area, the collage of what you're going to snapshot. That's all in green. That's stuff that's ready to be committed. Stuff that you've changed, that you have not added, and you are not saying you're ready to commit it. So it's files that you have already made Git aware of in the past. So they are what are called tracked files. You have added them at some point in time. And you've done changes to them, but you haven't told Git, I want to put those, I'm ready to put these. And then finally, you have untracked files. These are just files that are in the folder somewhere. You've never added them, they're brand new, and until you do add them, Git doesn't care about them. So they could just be trash files, they could be compiler output that you don't actually care about. But when a file is untracked, Git doesn't care, it's not interested in it. Git blame, this is a very nice one. Git blame. So, yeah, you pass Git blame a file path, and it will show you the latest commit, hash, and author name and email for every single individual line. So, for example, if 2 years ago someone changed line 10 of your C++ source code, then you'll see the commit for all that time ago. And if line 50 was changed last week, you'll see the guy for it. So if you find a bug, you use Git blame and see who was responsible for it. And then go and blame them.
I think you can specify both the file and an action to start with.
You can also use hashes, yeah.
Okay.
I think if you give it a hash, it just lists all the files on that.
And branches.
Yeah.
There are also some good plugins for text editors that automatically use it in Visual Code Studio. No, Visual Code.
Visual Code.
VS Code
To
at work.
be fair, usually you go on the bracket or GitHub.
Blaming. Yeah. Git bisect. This one's really good, and actually it's really simple to use. So imagine you developing an application and suddenly you discover that it randomly crashes a table. You don't know why. You don't know what the hell broke it. But all you know is that a week ago everything was fine, and now suddenly it's not. The regression test started failing. You don't know who broke it. So what you do is you call git bisect with two commit hashes. One is the commit hash that you know was good. So that the point in time that you know it was good. And the second one is the point in time that you know it's bad. Ideally, they should be as close together as you can make them, but realistically, you're probably not going to know. So you're going to take the good is going to be good, the bad is going to be right. And then what happens is, so that's kind of it picks it, and it checks it out for the file system and it says go and test it. So you go off and test it and see if it's good or bad. And you tell Git this is on the hardware, this is good, this is bad. And you can say this Git was good. It goes off. This is obviously an algorithm, it's like a binary search effectively. But Git then goes off to the commit and says test this commit. So you go and test it and you think it's good or bad again. You keep doing that. You keep answering Git. Whether a commit was good or bad, and I'm assuming you can actually accurately do so. You should be able to. Eventually Git will stop asking you and you can say that was a commit. It will tell you the actual commit to introduce the bug. And then you can go and blame Flower over that problem. And hopefully fix it because you've now found a piece of code that caused it. So another important one is git merge versus git rebase. So when we spoke earlier about this concept of having divergent histories, right? You've got these two commits here, developer A goes up here, developer B goes up here. Well, there's two ways to bring that stuff back together. So you can either use git merge. So that means that developer A got his code in, right? So obviously his code is now on master. The developer B, which wants to get his stuff in. What you can do is you can call git merge and you can merge this into here. So he makes a merge commit that says, so he does git merge. And what that does is he then ends up with a new commit here, it's a merge commit, and it's going to be this one, plus this one. And then that's now master commit to update that. A logical history. Alternatively, what you could do is you could git rebase. And you develop the same code, the exact same code. Although unfortunately, we do this if we end up with merge versus the option. But essentially, what git rebase does instead is it just says let's replay it like a sort of tape. So again, it extracts this logical change, which sort of holds it off to the side for a second, and then it updates to this guy here. So imagine if I sort of have these got one. So we're going to dealt with the first two for these, and this one, it's up here, so that can operate stuff. And then what it does, it just takes this from here, so instead of going here, it just gets replayed. Internally, it's actually generating new commits. So the commit hash of this will be completely different afterwards, because it's actually just taking logical chain, taking the message load, and then generating a correct commit at the same logical chain and the same message. It uses cryptographic hashes, SHA-1, to identify it, and that's based on the data inside the chemical inside the message timestamp. And obviously, because its parent is now different, it's commit hash is part of that data. Okay, the message is the same. You don't need to put it in hash. It's got the same message, the same content. And now, because it's just rebase, it's as if you did this all along. It's as if when developer A did his work. You just went and grab that, and then you did your work after. You didn't really. You worked in parallel. But it just looks like really nice, linear flow. And generally speaking, I recommend rebase over merge. When it comes to looking through the history of your project, the master branch, of course, it's so much easier to read if it's just a nice linear flow. If you start getting loads of merge commits, it doesn't look as pretty. It's probably not going to be that difficult to read through. I would say it's massively, but I'm in the rebase camp. There's plenty of people that I'm sure will disagree with me, and it's a matter of taste somewhat. But I feel the rebase is the way to go. All right. So, oh, one question. Yeah, go ahead. So, you raised a very interesting point. So, for large teams, and they need to be pretty big, there is a way to use merging that makes sense. But you don't use it sort of across the board. You have sort of a pyramid structure. And the best explanation I can give for this is actually the Linux kernel, because this is how they do it. And it makes perfect sense. So, within Linux, you've actually got an ecosystem. You have a pyramid. So, if I make this down quite easy. Okay, so I have to make it this way. So at the top we've got Linus, yeah? So Linus, top dog. He is the guy that releases Linux when he's ready for it. And then down from him we have, say, Dave, who does networking. I can't remember his last name now. So then we've got network. And then we've got, say, who's the best drivers? I don't know, we'll say drivers. So we've got drivers. And then maybe we've got, say, Andy Team, whatever. Yeah. Stuff, right? Staging drivers, something. ARM, MIPS, embedded. So these guys filter up to Linus. And then within networking, right, we'll have, let's do that for out. There's NetFilter, right? That's firewalling. So we've got the NetFilter guys, and we've got the Intel NIC guys. Ethernet network cards, basically. So they filter up into NetFilter. And then inside NetFilter we've got IP tables. And we've got IP set. So speaking from experience in this, so with the IP set group, right, it's very small. So what happens is that I actually change it to them. So as it was developed, I would rebase as part of this particular project. This is actually a concrete thing. So my IPs have changed as I just do a rebase. So then the guy that gets stuck in there could create that episode. And then the NetFilter maintainer will come along. This project doesn't strictly have any code directly connected into it. It's a super project. So, and there's all still one repo, there's all still one Git repository, but there's different people working on it. So then the maintainer of the NetFilter piece will take IP tables and take IP set changes, and they'll merge them in. So these individual projects are done by a merge mix. And then Dave, who maintains networking, will take from the NetFilter maintainer and from the Intel maintainer, and merge those in networking. And the drivers guys will do that for their stuff, and the stuff guys will do their stuff. And then Linus finally will do merge commits all of it. So when you're working in small concrete teams who actually do your code, you can just use rebase, that's fine. But then if you're dealing with this hierarchy of pure maintainers who are actually just bringing code together, then these higher layers are really merged. With the bottom, sort of the leads, probably arguably shouldn't do merging. All right, so we're going to have a crack at hopefully a surprise practice session if this all goes well. So we're going to have a go at creating a branch, writing some code, pushing a branch, and then merging a branch. And, with any luck, there should be a GitHub repo for this, if memory serves. So, where are we? Here's one I made earlier. Right, this is going to be quite far in the past. Which one was it? Was it in here? I'm not sure it was in here actually. I'm sure we had a example for it. No. You know what? Let's take pointers 101. That might work for us. Yeah, we covered pointers, right? So let's do this. So go over to CPP London Uni / pointers 101. So I'll write it on the board. GitHub.com / CPP London Uni / pointers 101. And then if I bring these slides back up. Yep. Well, the point isn't really to understand the code, so don't worry about that too much. It's just a random repo we picked. So clone it. Fork it. Fork it. And then clone your fork. And then I want you to create a branch. So git checkout -d. Fork and then clone. So go to the fork button. And then you can clone it. So write in the code, I don't care what you write, you can inject garbage into it, whatever you like. And then you're going to push the branch, and then you're going to fling a merge request to me, and I will take a look at them. Yeah, so click the fork button, clone the fork, and to take you to your own version of the code. Do something, whatever. So it's trash. Push it, git push, and then finally submit a merge request for me to look at. A pull request if you like, as GitHub calls it. Yes. No, that's not true. You can. It's asked for using a password. Yeah. Oh, fine. Change it, don't care how. Just some crap on it. Yeah, submit, push, and make a pull request on the website. All right. Well, we're on the pull request. We'll see if anyone does one.
Yeah. Oh, it's added. Like, and I added everything. So there's no.
For the purpose of this test, unless it's going to be agonizing it doesn't matter. If you want to practice a bit, keep yourself to not chuck garbage in it, please feel free. Like you can literally, your git ignore should literally just consist of like cmain -build -star on one line. That should ignore everything in there.
Yeah.
Yeah, so make idea. Yeah, so have one line you've got idea, have one line the cmain -build -star. Oh, no, that's the same head.
I have no idea.
No, that's right. You can change anything, right?
So is that you're going to do? Send a request. Michael, can you do my screen?
Build -star, right?
Oh, yeah. That is true. That is true. No, that's true.
Apparently he never liked that time.
Well, it's more bigger, isn't it? This is great.
Yes, there you go.
You can be better.
Cool, we've already.
Yes, I'm going to ask you about
So we got one already. They've got a commit. And if we look at the files change, so I can see this. Nice, okay. Whoever wants to go home and eat, it's okay, we round off at 9 o'clock, no worries. Yeah, cool.
I was wondering why I kept buzzing. It's because I get an email every time
this
repository gets
Giacomo's done it. Heather says done it. Zenith UK, is that someone in the room or someone remote? Oh, it's you. Yeah, excellent, well done. Oh yeah, okay. And let's see who's keyboard breaking. Yeah, there you are. Nice username. Excellent. We've got 4 success stories so far.
I just realised I forgot to burn, so I'm just trying to go back. I can't go back. Or you could push it to your how if I wanted to go back, it doesn't seem to want to get rid of the file.
I think I'm not able to cast
Yeah, we got another one. Excellent.
Just a quick reminder, if you didn't put your name,
Nice.
please do.
run it through, yes?
I can mercilessly reject all your pointless pull requests en masse as well. Look at this, it's great. It's like, ha.
Okay, yeah. Full from, yeah.
Think mine. Yeah. Alex, you're not this fit.
Oh, you needed to do 2 merge requests, not just 1. Oh, yeah. Alex, excellent. Mm-hmm. Oh God, go on. That's not good. That's not some cake thing. Alright, we've had 7 success stories, so some of you have learned something new.
So I just need this new iOS. I did do that.
Yeah, I did. But yes, if anyone missed it, I'll just show it again. So this is the interface for merge requests. As you can see, the person that wants to merge says something. You can see the individual commits. There's only one here, obviously. Title, message. You can obviously look at them directly if you wish in this tab. And you can see the logical changes. You know, just made a file, added a line. Cool. And then I can obviously do stuff to it here. I can review them, give a summary, and I somewhere have the power to actually merge it if I wanted to. So I can merge it. I've got actually loads of options. You can rebase them. Like GitHub is really cool for this. It lets you pick how you want to merge, which is lovely. And additionally, I can just say no, go away.
I'd like to leave a comment to say why you
Yeah. No, unfortunately, none of you are going to get an explanation as to why they were closed. I think you'll guess why, though. Phil's done one, excellent. Let's see. Laura's done one. Simon's done one, excellent. So, I closed Giacomo's because he's already got one. So we've had 9 successful so far.
flood of pull requests. Now that you know they send me
we're all getting like emailed by a lot of you. We've moved the GitHub Classroom to a different organisation since.
Where am I on holiday in Greece and suddenly my phone starts going mad last week.
You know you can turn those notifications off, right?
Well, yeah, I found that out.
The hard way. Yeah. No, points only ones from last year. GitHub own it. They own it. I mean, you can set your own up if you are paranoid and don't trust them, or you want private
So
stuff.
most companies will have their own
Yeah.
server.
Can you use your own server through the website?
No.
Now, there are web interfaces, but you can't just get
Can you use web?
not unless you're using GitHub.
So there's a self-hosted one called Gitty, aka Gogs. They're like they forked. They look pretty much just like GitHub, but you can host it yourself. It's written in Go as well, which is okay. It runs faster than Ruby on Rails. Okay, so we're getting close. So I think I'm going to allot 10 minutes. We can finish a little bit early today. I think is reasonable. So. Wait. I need to switch the damn OBS again. This is such a pain. You don't remember this from last week? Yeah, you literally said the exact same words. So, final thoughts, really. Git is a wonderful Swiss Army knife for development, but most importantly, any questions? No questions?
Good.
Good.
Would you mind to tell exactly what does it say in this screen?
Tom, would you like to read out the blue screen of death in Polish for us?
Jeżeli po raz pierwszy widzisz
Translate it. Translate it.
If you see this screen for the first time, stop.
I think some of the characters are a bit corrupted.
Yeah.
No, does anyone have any questions? Or was it just the case that you still have no idea how Git works and you do? Yeah.
How many people feel more confident about Git now? Hands up. Okay. How many people still feel unconfident and they need more on GitHub?
How many people are going to go home and practice on GitHub and read Git cheat sheets and stuff like that? Okay, good.
Does Git stand for something, or is it just Git?
No, it's just Git. The best I can give you is someone asked they asked Linus about this, and his answer was, he says, I'm an egotistical bastard. I like naming projects after myself. Linus, Linux, now Git.
Because Git means in some dialect
In English, in British English, a Git is someone who's slightly disagreeable, and you're being a Git. Disagreeable person.
You get to practice all this next week because we're going to have a GitHub classroom exercise for the big one.
As you go through this course, you're organically going to gain experience because you're going to be using GitHub Classroom. Also, as recommended homework, one, GitHub have a tutorial, so I can actually show you that real quickly. Because we actually have time. Let's see. Which one, sorry?
On Atlassian, there is a
Atlassian.
Yeah.
I don't like Atlassian. I think their products are massive.
That I agree completely, but the tutorial is not that way.
But he's online. He's an online one.
Okay, someone try and commit the JavaScript file in C++.
Wow.
that's
Yes. So try.github.io. It's a wonderful resource. I recommend looking at it. The Atlassian one I haven't evaluated. I don't know. But this is a great place to go. And as homework, I recommend going through it.
I checked both, for example, the Atlassian is pretty good if you want to see the difference between checkout, rebel, the user. It has a pretty good one.
Okay, worth checking Atlassians. Yeah.
Yeah, I don't know if this is correct. The way Git works is you sort of differentiation of files to check the files for differences, right, before deciding what to do.
What do you mean in terms of deciding what to do?
Well, it checks files for differences before it stores the rest of it.
No, so each commit is literally just a point in time, right? So if I have like point in time A and point in time B, like 1 and 2, then the difference comes out naturally by looking at the state of the files at that point in time and the state of the files at that point in time. So the diff itself is just generated from.
Okay, it stores it.
It's just generated from the difference.
Okay. Well, what if there's a bug in the difference?
Well, then you're going to get some very disturbing difference. Like if that's well, I mean, what if there's a bug in Git? Anything from remote code execution that gets your computer owned to Git just crashing and you being annoyed. There's literally been there's literally been bugs in Git that have been remote code execution exploits.
But can any of the bugs actually change the files?
Potentially, yeah. So there's a bug in Git where on Windows it would check out files to what are called NTFS alternative data streams. So you'd end up with content you couldn't even see, unless you knew about it. So there's been several bugs in Git, and yes, if something really bad and stupid happened, then it potentially could cost you some data. Git is very well tested, and these things are very rare. It's extremely robust. I mean, the odds of something, the biggest risk is someone maliciously trying to destroy your stuff. The odds of Git having a bug in it that would just make it suddenly magically disappear is extremely low. A bug that someone malicious could exploit to cause destruction, possible. But generally speaking, the idea is you want to keep files around. Like, you know, within a workplace, every developer's got a copy of all of the code. The server's got a copy of the code. So even if like half the development team quits and they blow up the server before they leave, you've got some people left who've got local copies. Everyone's got a whole repo. Say that again. A private hosted Git, yeah. Well, I mean, if you own your own computer, like, I don't know, you've got a server in a rack unit server or whatever in a data center, then no, you don't pay for it. Because you know, it's not GitHub though. There's open source projects that are just. GitHub is just a website around Git. So there's other websites. There's GitLab, that's written in Ruby on Rails. There's Gogs and Gitty, they're written in Go. They're just a website that goes around Git, and you can stick them on your own computer, on Linux box or whatever. But anyway, we are 3 minutes away from 9 o'clock, so it's our rounding off time. I hope you all enjoyed it, and if I can quickly get back to here. That's it.
Cool.
Yeah, thanks everyone.
Thanks everybody for Oliver. It was a longer session. It was a bit longer session. Tristan, I think we will do the vector 3 minutes. I think there will be no point to the vector.
I'll tell you, we're all staying at
So obviously we're going out to pub, so everybody's welcome to join and buy these guys a pint or two, as saying thank you from us for their time. And I hope to see you on Tuesday.
Yeah.
Oh, yeah.
The GitHub, get familiar with the GitHub.
I mean, OBS and everything is really very taxing on it, as it were.